We've been talking about capillary bed uh, transfer of materials, and now we're going to talk about a subject called capillary bed perfusion. Let me start by defining perfusion. Perfusion is defined as the number of milliliters of blood that will travel through a gram of human tissue in 1 minute. That is perfusion. So when you are very cold, your skin gets very little blood going through it. And so that would be a decrease in perfusion. But when you're very warm and you've been exercising, so a lot of blood is going to your skin to radiate off that extra heat, then we would say there was an increase in perfusion. I don't know about you guys, but when I think about capillaries, I usually think about them as if there's always blood going through them all the time. But there's not. As a matter of fact, particularly with our skeletal muscle, the difference between the amount of blood going through every gram of your leg muscle per minute when you're just sitting there compared to when you're running super hard, it decreases and increases by 20-fold. Well, that's kind of crazy. How does that exactly happen? Before we talk about the details of that, I want to introduce you to the concept of the capillary bed. With capillaries, they are organized in a different way than arteries and veins are. In general, arteries and veins are organized more kind of like a tree, how there will be one branch that divides up more, that divides up more. It kind of is branching. That's the way arteries are. Veins are kind of the opposite. Little ones come together, come together, come together, come together. Capillaries are different. They are not branching in that sense. And so we describe the organization of capillaries as being capillary beds. Here we've got an image. I know it's going to remind you of the last one that I showed you, but it's different. In this one, this is a structure called a medarteriole, and all of this is going to be the capillary bed that is controlled by this medarteriole. I want you to notice that if you are a red blood vessel and you're traveling through this capillary bed, you could go this way and then go that way, and then go here and then go there and then go back there and then go up there and then go down here and then go down there. And so capillary beds are not organized like trees. They don't have a branching appearance. They're more like a net, like a fishing net. What do I know from fishing nets? But like a net, okay? And it's because they're organized like a net that blood pressure inside of capillary beds will drop off very quickly as blood goes from one side of a capillary to another. And that is germane to our discussion of capillary transport, the way the watery part of the plasma can leave at the beginning of the capillary bed and jump back on at the end. But let's talk about perfusion. I generally, in my head, think of our capillary beds as being like this, that all the time they've got blood running through them. But that's not at all true. Most of the time, most of your capillary beds don't have any blood traveling through them at that moment. So if I were to divide up all of the capillaries in beds inside of your leg muscles as you're sitting there watching this, then right now, capillary beds 1 and 2 are closed, but capillary bed 3 is open. Oops, now capillary bed 3 just closed, and 1 and 2 and 4 and 5 just opened. Oops, now all of them are closed just for a moment. Now, wait a minute, capillary bed 9 just opened, right? They're constantly opening and closing. Well, who's opening and closing them? Well, there are a few factors, but the ones that I would like you to focus on are the autonomic nervous system and also on tissue control factors. Now, in these areas that are depicted as yellow in these two artist renderings, there are cells that are living there. Let's imagine they're your skeletal muscle cells. Now, the cells that are living right there, they're the ones that know whether they need more oxygen and whether they need more glucose, right? So wouldn't it be swell if it would be those cells that were somewhat in charge of whether blood is going through this area or not? And when it comes to skeletal muscle, the skeletal muscle cells are largely in charge of whether blood is traveling through their capillary beds or not. Right now, the cells that are your muscle cells in your legs are just sitting there. So they ate, they got glucose and oxygen a little while ago. So they're completely cool right now. And they're like, yeah, no, don't bother to send any blood through us. We're cool. So the blood just goes zipping right on past, right? But if they start to run out of oxygen or they start to feel hungry, then they will send out signals that'll cause these little smooth muscle cells, these little sphincters, it'll cause them to relax. And when they relax, the sphincters open and then blood goes rushing through. As it rushes through, it will deliver oxygen, it'll deliver more glucose, and then it'll take away the waste products that have built up, and then the blood goes back to your heart, and then the liver, the skeletal muscle cells will go, oh, okay, we're good for a while now. It's kind of like you may be trapped inside your house because of this COVID-19 thing, and maybe you're having food delivered, but you don't want the food delivery guy to come to your house every half hour, right? You're like, no, don't keep coming and delivering pizza to me. I don't need it every half hour of the day and night. I'll call you when I need you. And so most of the time, there's not a pizza delivery guy at your door. You call him, he comes, you have pizza, and then you're good for a while longer. So one of the things that controls the opening and closing of capillary beds is the buildup of products inside of those capillary beds. Now, I don't want to confuse you with this, but I want to make it clear that this story that I told you is particularly specific for the skeletal muscle. Skeletal muscle, when it has had enough oxygen and plenty of glucose, and the waste products all got washed away, then the environment in these little yellow spaces is actually a little bit on the alkaline side. So it's a little on the high side of the normal pH, and there are no waste products building up. But after a while of not having enough oxygen in there, then waste products build up. What are those waste products? Well, with skeletal muscle, it's likely to be carbon dioxide. And wherever there is more carbon dioxide, there will be more acid. We'll talk about that more when we get to the respiratory system. And also there will be a buildup of waste products like lactic acid. All of those things will make this environment more acidic. And when it comes to skeletal muscle, it's more acidic that will cause these little sphincters to relax, to open up, and to allow blood to run through. That's not true for everywhere in the body. It's particularly true for skeletal muscle. There are other things that will open and close capillary beds. Remember when we were learning about the parasympathetic and the sympathetic autonomic nervous systems? And when we were talking about the sympathetic nervous system, we learned that the receptors for norepinephrine are called adrenergic receptors, because adrenaline, adrenergic. And we said that there were different subcategories. The different subcategories of adrenergic receptors we focused on were beta 1 and beta 2, but there were more. The beta 2 receptors will cause the bronchioles to relax or dilate. We'll get back to that when we talk about the respiratory system. But those beta 2 receptors can also cause the smooth muscle in the arterioles and skeletal muscle to relax. When you have adrenaline running through your body, more blood goes running through the capillaries of your muscles because adrenaline, epinephrine, is going to bind to the beta 2 receptors. They're in these little cells right there and cause them to relax. And when they relax, more blood goes running through. Simultaneously, the alpha 1 adrenergic receptors will cause the smooth muscle of the arterioles in your skin and in your intestines, your stomach, to constrict. And that is why when you get an adrenaline surge, more blood goes through the capillaries of your skeletal muscle, less blood goes through your intestinal tract, and less blood goes through your skin. And that's why if you get a sudden fright, you will look really pale or greenish because of that effect on capillary beds. Now, let's talk about specific circulatory routes. There are 3 circulatory routes I want to mention specifically, and one of them is entirely relevant to this COVID-19 crisis that we're in the middle of when I'm making this video. Let's start with talking about the skeletal muscle. This is just a recap because I basically just told you about skeletal muscle. Skeletal muscle is very highly variable. When you're just hanging out there not doing anything, or maybe you're asleep, you've got very little blood going through the capillary beds. So the perfusion, the amount of blood per gram of tissue per minute, is very small. But when you're exercising super hard, you can have 20 times as much perfusion, which means 20 times as much blood flowing through every gram of muscle tissue per minute. And that is very effective because when your muscle's not doing anything, it doesn't need a lot of blood delivering stuff to it. And when your blood's exercising, it needs a ton. So this circulatory route is unusual because it is highly variable. Now that's the opposite of the brain. We'll be talking about the brain, and the way skeletal muscle perfusion is the opposite of the brain is because skeletal muscle is highly variable, but perfusion to the brain is really very constant. The difference between the amount of blood going through every gram of brain tissue per minute, one moment of the day to another, it only varies by a few percentage points. It doesn't even increase twofold, not even that. So you can see how very different it is. All right. The arterioles dilate in response to epinephrine because of beta-2 receptors, beta-2 adrenergic receptors. And so that is our special circulatory route, the skeletal muscle. We're going to do the other 2 circulatory routes on the beginning of our next video.